everyone, thank you so much for coming to this video. So today we're going to be going over integration by parts. So make sure you review the videos on how to carry out integration and other forms and how to integrate different functions, as that will come into useful for this video. So the learning objective for today is to be able to carry out integration by parts. So I'm going to explain how you do this, the formula, and then apply this to some questions. So like always, there's going to be timestamps in the description of the video, so feel free to skip to any parts you want to. But let's get started. So you can use integration by parts when you have two different functions of x, and you can't use integration by substitution. So if these look really different and you're like, oh, they can't be, like one can't be derivative of another, the reverse chain rule won't work, substitution doesn't seem possible, then you use integration by parts. So the formula for integration by parts is if you have the integral of u, which is in a function of x, multiplied by like a derivative dv over dx, and you want to integrate that, then that would be equal to ub minus the integral of v times du over dx times of dx. So if we try this with an exact, like a practice question, it will be more clear on how to actually use this. So if we have the integral of 2x e to the power of x dx, and we want to integrate this using integration by parts. So the first thing you want to do is you want to try and decide which should be your u and which should be your dv over dx. So this can seem quite tricky, as it may not be clear which one to use. Again, this will come with a lot of practice, but you usually try and decide your u, as you're going to need to differentiate that, something that will differentiate nicely to something that when you integrate this later, when timesing it by v, it'll be quite easy to do this. So normally something that like differentiates to a constant or to 1, that'll be what you would want your u to be. So in this case, we have the integral of 2x times e to the power of x. So we could call our u is equal to 2x, as we know that if we do du over dx, that will just differentiate that to 2. So it's quite a nice one. So now if we do dv, we call our dv over dx as e to the power of x. And then to find v, we just want to integrate e to the power of x. So that would just be equal to e to the power of x. So now we can just plug in all these values into our formula here. So we have that equal to u times v, so 2x times e to the power of x minus the integral of v, which is just e to the power of x times du over dx, so times 2. And if we do that, we get 2x e to the power of x minus the integral of this, which is just e to the x integrates to e to the x, so it's just minus 2 e to the power of x. Then remember your constant on the end. So that's how you use integration by parts. So you can apply integration by parts to find the integral of ln x, which is really handy. So let's try that out. So if you want to integrate ln x, as I said before, you have to do this by integration by parts, because there's no like set formula for the integral of ln x. Like, you know that if you differentiate ln x, you'll get 1 over x, but there's no way to integrate this. So to integrate it by parts, you just want to split up your ln x to get that's equal to 1 times ln x dx. So this is because you know how to differentiate ln x, and you also know how to integrate 1, so you can just split that up. So we could call our u ln x, because if you do du over dx, you just get 1 over x. And then if we call our dv over dx equal to 1, then our v is just the integral of 1, which is just x. So now we can just plug this into our formula here, and we get u times v, which is just x ln x minus the integral of v times du over dx. So that's just the integral of x over x dx, and that would just simplify to x ln x minus the integral x over x would just cancel down to 1. So the integral of 1 is just x, so minus x plus c. And that's your integral of ln x using integration by parts. So now that we've done some practice questions, let's try an exam question to see if you know how to apply this. So we have an exam style question here. Feel free to pause the video and try it out for yourself first. So we want to use integration by parts to find the integral of 3x squared times e to the power of x dx. So the first thing you want to do is you want to try and split this up to have a u and your dv over dx. So your u wants to be something that can easily differentiate and make your whole integration a little easier. So if you differentiate e to the power of x, you're just going to get e to the power of x. That won't really help you much. So let's call our u is equal to 3x squared. So that means our du over dx, that will be equal to 6x. And then if we say our dv over dx, that would be equal to dx. So then our v is just the integral of ex dx, so that would just be equal to e to the power of x. So then we can use this to say we want to find the integral of uv, which is just 3x squared times e to the power of x minus, so that integral, sorry, is equal to 3x squared e to the power of x minus the integral of v times du over dx. So v is e to the power of x and our du over dx is 6x, so 6x e to the power of x dx. So here we have 6x e to the power of x, and again we have two functions of x, so we can't integrate this like this. We're going to have to try use another method. So we can't use integration by substitution, like there's no like products of like derivatives, so we're going to have to use integration by parts again, and that if we do that, hopefully we'll be able to have a final answer. So again, we want to find a u and a dv over dx. So if we call our u 6x, then we would be able to get our du over dx is 6, and that hopefully that will mean we can integrate everything fully without needing to do anything else. So if we do that and we call our dv over dx as e to the power of x, then that means our v is e to the power of x again. So then that means our integral is now equal to 3x squared e to the power of x minus, we're now integrating this bit, so let's put this in brackets, minus uv, so 6x to the power of e to the x, minus the integral of v times du over dx. Our v is e to the power of x, du over dx is 6, so the integral of 6 e to the power of x dx. And we know if we simplify this, we'll get 3x squared e to the power of x minus 6x e to the power of x, and we can integrate 6 e to the power of x. That would just be equal to 6 e to the power of x. So we just plus 6 e to the power of x plus c. Then if we want to simplify this further, no need to, but if you want to, you just take your e to the x out and you get 3x squared minus 6x plus 6 plus c. And that's your answer to this question. So here is just noticing what you want your u to be, and then you just doing your integration by parts twice to get your final answer. So that's everything. Hopefully you found that useful and you now understand how to carry out integration by parts. So just memorize this formula that I've written below and just do some more practice questions just to make sure you fully understand how to apply this. Again, it's tricky to figure out what your u is, but by doing a lot of practice, it'll just get easier on how to spot this. So make sure you do that. But otherwise, thank you.